All right, on to part two. Um, so now we dealt with the case where the leading coefficient was 1. So obviously this should say not 1. So in order to factor an expression of the form ax squared plus bx plus c, where a is not equal to 1, now the way this technique works is a little bit more, as I like to informally call it, hand wavy. But we're going to find two numbers p and q such that, so we still need them to add up to make the middle term. So p plus q equals b. And now instead of just multiplying to make c, p times q has to equal a times c. It's a little bit more complicated to see how this technique works, and this is an A, by the way. There is a fantastic Khan Academy video that I will link to you later if you're curious to see how this technique always works. It definitely felt like magic the first time I used it, but I might be a strange person. So, 6 times 3 is 18. So we have to list factors of 18. And we need to find the pair that adds to 11. So I have 1 and 18, 2 and 9, and there it is, 2 and 9. 2 plus 9 is 11. Okay, now this is the part where, stay with me. So I don't skip straight to my two factors. It's not x plus 2, x plus 9. It's not 3x plus 2 and 3x plus 9. Just watch. So my middle term, my 11x, I'm going to split that. It's going to become 2x plus 9x. And the rest of my equation is going to say, this is an expression. The rest of my expression is going to stay the same. So I have 3x squared plus 2x plus 9x plus 6. Now I'm going to look at my first pair of terms, 3x squared plus 2x. And I'm going to factor out the GCF, greatest common factor. And here, the greatest common factor of 3x squared plus 2x would just be x. So I have x times 3x plus 2 plus, this plus sign here is important. Don't forget about it. Anyway, then I'm going to factor out the GCF from this second pair of terms, which is positive 9x plus 6. And from here, so they don't both have an x, and they shouldn't, but these numbers are both divisible by 3. So I can factor a 3 out of that pair of terms. And when I do, I get 3 times, so 3 times 3x would give me 9x, and 3 times 2 would give me 6. So right now we have x times 3x plus 2 plus 3 times 3x plus 2. And this is the part that always felt like magic to me. But what's happening, 3x plus 2 is now common to both terms. And in fact, it would be the GCF. So because 3x plus 2 is the GCF here, the greatest common factor, it can be factored out. And if I factored 3x plus 2 out of both of these terms, I would get x plus 3 times 3x plus 2. So the x plus 3 comes from this. I have x and I have plus 3. And now it's factored. It feels like magic, but it's factored. So in the second example, there's a wrinkle here. I don't like when I have negatives here. It's annoying when you have a negative leading coefficient. So I'm going to factor out a negative first. And in fact, not just factor out a -1, all these terms are even. So I'm going to factor out a -2. So I'm going to rewrite it as -2 times, and then I get positive 5x squared minus 6x plus 6x, because I factored out -2, and plus 1. And now now I only have to factor the remaining part, so I'd have to factor this part out, and my -2 is going to go along for the ride. He's just going to hang out front, and I don't have to worry about him until the very end. So now that I have this inside expression, I need to find numbers that multiply to 5 times 1, which is 5, and add to 6. Now, the only things that multiply to 5 are 1 and 5, and they happen to add to 6, so we are in luck. So remember, my numbers are 5 and 1. That was my P and my Q. So now I split 6x into plus 5x plus 1x. So I have 5x squared plus 5x plus 1x plus 1. If you find yourself wondering, how do I know which order to put the 5x and the 1x in, the answer is it absolutely doesn't matter. And if you're feeling confident right now, I want you to try it in the opposite direction and see if it works the same, because it should. So I take my first two terms, and I notice that they have a 5x in common. So 5x is factored out. And I would be left with x plus 1. Now, with this 1x plus 1 here, there's nothing I can factor out. It's just x plus 1. But for the sake of convenience, I'm going to write it as I factored a 1 out, which doesn't change anything, right? It's plus 1 times x plus 1. And now I can see that my two factors are 5x plus 1 and x plus 1. So we have 5x plus 1 times x plus 1, and then our -2 that went along for the ride. So it still works if you don't factor the -2 out at the beginning, but factoring the -2 out makes your life easier because you're dealing with smaller numbers. So anytime you have a factorable expression and you notice common terms that you can get rid of by factoring out, you should factor them out. It saves you a lot of trouble. Rather than finding numbers that multiplied to 20 and added to -12, I only had to find numbers that multiplied to 5 and added to 6. So fewer things to check. All right. Now you might look at this equation, this solve, and you see two things multiplied together equals 2, and you might think it's already easy. We just split it up and set them both equal to 2. But it doesn't work because the zero product property that we want to use, that has to be equal to 0, right? So if we're solving this, we actually first have to use FOIL to multiply it all out, and then set it equal to 0, and then factor it. So first we're going to multiply this out, and we get 6x squared minus 3x plus 4x and -1 times -2 minus 2 equals 0. Now equals 2. And then now I'm going to combine these terms and subtract the 2 from both sides. So my equation that I'm actually going to factor to solve this equation would be 6x squared plus x minus 4 equals 0. So I have to find numbers that multiply to negative 24, because that's 6 times 4, and add to 1. And I think this is the part, so we need the bigger number to be positive. 2 and 12, 3 and 8, 4 and 6. So this is the part where we stop because Mr. Trenfield messed up. And the copies are already at school and made, so I can't change this problem. So on to number 8, right? So negative 16 squared plus 8t plus 8 equals 0. We still can take from this the lesson that you have to set it equal to 0 first to factor it. But sadly, your teacher's dumb and he messed up. It's been a long week, guys. So this equation here. So this is similar to the example 6 here because I have a number that I can factor out. But since this is an equation, not only can I factor it out, I can just get rid of it because it's an equation and I can divide both sides by the same number. And that number I'm going to divide by is 8 because all of these terms have an 8. And I don't like when this is negative, so I'm going to divide everything by negative 8. Because 0 divided by negative 8 is still 0. So this equation now is easier. It becomes 2t squared minus 1t minus 1 equals 0. This is much easier to deal with. Now, 2 times negative 1 is negative 2. So the only numbers that multiply to negative 2 are 1, negative 2. So these are my two numbers, positive 1, negative 2. So I split my negative t into 2t squared plus 1t. If you don't write your t's with a curly here, then you're going to confuse yourself. So 2t squared plus 1t minus 2t minus 1. And then my GCF in the first two would be 1t. So I factor out t, and I'm left with 2t plus 1. And then here, so this is negative 2t minus 1. So we can't factor out anything but a 1, but notice since these are both negative, I can factor out negative 1. And I'm left with 2t plus 1. And now I can see that my factors are t minus 1 and 2t plus 1. If you're factoring and you don't get the same term here in the parentheses at this point, that means you made a mistake somewhere. Often it means that you didn't factor out the greatest common factor. You might have factored out something less than the greatest common factor. So be on the lookout for that. Anyway, here my factors are t minus 1 and 2t plus 1. And setting these equal to 0 would give me solutions of t equals 1 or t equals negative 1/2. All right, so lastly we have this word problem. So the area of a rectangle is 6 square meters, and the width is 1 more than twice the length. So that means, first of all, we know area is length times width. So length times width is 6. And the width is 1 more than twice the length. So that means W equals 2L plus 1. And now that's going to help me write my equation. So I'm going to have L times 2L plus 1 equals 6. And now, just like this example here where I messed up, we have to distribute it out and set it to 0 before we can solve, or before we can solve by factoring. So this would give me 2L squared plus 1L, and then I'm going to subtract the 6 already. So minus 6 equals 0. Which means I need two numbers that multiply to, so I need numbers that multiply to make negative 12 and add to make positive 1. So my factors of 12 would be 1, 12, 2, 6, 3, 4. And since I want a positive L, that means my bigger number is the positive 1. And we can see right there, 4 and negative 3. So I split my 1L. I got 2L squared plus 4L minus 3L minus 6. And my GCF in this first pair of terms is a 2L. So this is one of those cases where it's easy to, if you only factor out an L, then it wouldn't work. So we factor out 2L, and we're left with L plus 2. And here we can factor out a negative 3. So minus 3 times L plus 2. Which gives us our factors of 2L minus 3 and L plus 2. And then solving, so if we set both of those factors equal to 0, we would get L equals 1.5. From the other one, we would get, so L plus 2 equals 0. We would get L equals negative 2. But remember, we're solving for the length and width of a rectangle. So this answer doesn't make sense in this context. Can't have negative length. And that's usually what happens with these quadratic equation word problems, is we'll get one answer that does make sense and one answer that doesn't make sense. So the length is 1.5 centimeters, and the width is 2 times that plus 1, which is 4 centimeters. All right, so you've got the 4-3 skills practice to work on. That is all problems, and you must show all work to receive a stamp.